Good morning, students. Today we will talk about measurement and scaling concepts. What do you mean by a concept? Concept basically is a generalized idea about a class of objects, attributes, occurrences, or processes. But when we talk about operational definition, it is little different. It specifies what the researcher must do to measure the concept under investigation. Operational definition actually add meaning to the concept because concept is such, for example, loyalty, power, job involvement, and something like this, right? But when we talk about operational definitions, it would be like it would actually clear that what it might mean when it comes to your research study. Operationalization of concepts is very important in research study, and this is why we are studying measurement and scaling concepts so as to define them operationally. For example, media skepticism. Let us have a look at conceptual definition. Media skepticism is the degree to which individuals are skeptical toward the reality presented in the mass media. That is it. Or when it comes to operational definition, media skepticism varies across individuals from those who are mildly skeptical and accept most of what they see and hear in the media, to those who completely discount and disbelieve the facts, values, and portrayal of reality in the media. So, this is how we can differentiate between conceptual and operational definition of something. Let us have a look at one example. Please tell me how true each statement is about the media. Is it very true, not very true, or not at all true? The program was not very accurate in its portrayal of the problem, or most of the story was staged for entertainment purposes. The presentation was slanted and unfair. How would you rate these? Like whether these are very true statements, not very true, or not at all true? It depends on whether you are talking about just the concept or operational definition. So we need to define the objects or say variables operationally so as to get into the research study properly. What do you mean by scale? Series of items arranged according to value for the purpose of quantification. We will be studying scales and we will see how we arrange items as per different scales. It is a continuous spectrum. For example, nominal scale. Nominal scale basically is you will be just giving numbers to people randomly. For example, there are 100 people, and out of those 100 you have to pick 10 people randomly. So you will be randomly providing them chits from 1 to 100. That is basically a nominal scale. Providing value of nominal scale is like this. We will be studying them as per the scaling properties as well just after this. This is ordinal scale when you are trying to compare something from the other thing. For example, whether this car was faster than the other one or not. This is actually the interval scale when you are still comparing 2 or 3 things, but this interval is same in all the comparisons. And this is ratio scale when we say that this has actual value. For example, money. Let us discuss them as per the scale properties. Number 1, whether it is uniquely classifying the things, or it preserves an order, or its interval is equal or not, and whether it is a natural zero or not. We will be classifying these 4 scales on these 4 properties, right? Let us start with nominal scale properties. It is actually just uniquely classifies the things. For example, there are 2 students who has got the chit of 21 and 25 randomly. For example, you have 50 people in a class and you will be assigning them the roll number, maybe alphabetically, or maybe just the way they are sitting in the class right now. This Or maybe people are sitting in a group and you will start providing them chits of numbers like from 1 to 50. This is actually providing nominal scale value. This has nothing to do with actual analysis, but yes, rather we provide nominal scale value because we do not want to get confused with the names. It is more easier to remember the numbers rather than names. For example, you are going to conduct a study on 100 companies for 5 years. You cannot remember the name of every company all the time. You will be providing a serial number to the companies from 1 to 100. That is basically a value provided with the help of nominal scaling. When it comes to ordinal scale properties, yes, it is uniquely classified, but it has one more property which says that it preserves the order. In case of ordinal scale values, we actually see whether you have won or not. It's a win or lose situation, or you talk about a place, or you talk about a show, whether it was good or bad, something like that. For example, you might be talking about whether person A is more intelligent than person B, or whether person B is more intelligent than person C. Like this, such comparisons would yield results as per ordinal scaling. You will be basically ranking the order of their preferences. Basically, we talk about preferences when we talk about ordinal scaling, but their interval is not same here. For example, I have got 4 baskets in a row and I'll be choosing one over the other, and I might say that this is the least preferred one and this is the most preferred one, and these two are in between. Or maybe I assign them the number as per my preference as 1, 2, 3, 4. Then I am trying to say that I prefer 1 over 2 and 2 over 3 and 3 over 4. This is how you might rank the your preferences. This is ordinal scale property. Then when we talk about interval scale properties, it add one more value. Yes, it uniquely classifies the parameter, then it preserves the order. Yes, 1, 2, 3, 4, 5. This way it is also a kind of ranking. But the only thing differs here from ordinal scale is that it equal intervals, that it would be presuming in equal intervals in between two items. For example, when I say that that a race is going on, and you will be assigning the horses which are there for the horse race. You will be assigning numbers to those horses randomly 1 to 10, and you focus on horse number 7. You will be talking about horse number 7 all the time. So it is just that you have the advantage of that chit 7 with the horse. That is nominal scale. When you say that this particular horse is faster than that horse, for example, horse number 7 is faster than horse number 5, then you are trying to preserve the order. That is your ordinal scale. But when I say that horse number 7 is more preferable than horse number 5, and horse number 5 is more preferable than horse number 3, and I might want to say that horse number 7 is 2 meters away from horse number 5, and horse number 5 is 4 meters away from horse number 3. This way, if I classify the things, I am trying to put some intervals here, and I am trying to define intervals by 1, 2, 3, some ratio. This is actually your interval scales, because I can say that there is a difference of length 1 between 7 to 5, and there is a difference of length 2, because I am saying 2 meters, then difference of length 2 between 5 and 3, because this is the double the difference. So I can actually go with some intervals. For example, we generally talk about scaling concepts in a way. We ask people to rate things on a scale of 0 to 5 or 1 to 10. In that case, these scales have equal intervals. I might say 1 for strongly dissatisfied and 5 for strongly satisfied. 4 for just dissatisfaction, and 2 for just satisfaction, and 3 for neutral. So I am trying to keep a regular interval among them. So when it comes to intervals, when it comes to ordinal scale, yes, there was a difference, there was a kind of order, but it was not having equal interval. We were not talking about the intervals at all. But when it comes to interval scale, we talk about equal intervals. For example, consumer price index, there is a base called base for that particular index, and on that basis you go with equal intervals. And the same way in case of temperatures. Now let us discuss what ratio scale properties are. It contains all the properties of scale. For example, yes, it uniquely classifies the item, then it preserves an order, equal intervals, and natural zero is also there. For example, weight of a person or distance between two items, these are actually continuous, and it actually represent a natural zero as well. Then how would you measure indexes? It is very important because we are going to do that in case of data analysis. Attributes are a single characteristic or fundamental feature that pertains to an object, person, or an issue. So you know that we are talking about a person's or an object's characteristic when we talk about attributes, right? We will be talking about attributes when it comes to attitude measurement in next video. Then composite measure. Composite measure of several variables to measure a single concept is called a multi-item instrument, and that composite measure basically is known as index generally. For example, when you are trying to define one company by its attributes, for example, this company falls in the category of manufacturing industry, then manufacturing may it is steel industry, right? These are the attributes of a company, and this is in the second number when it comes to the comparison in steel industry. But when we talk about composite measure, we will be talking about all the companies falling in one index. For example, BSC index. BSC index is an index which consists of 30 companies, overall top 30 companies which are registered on or say listed on BSC. So this is how we will be making an index. Top 30 companies, top 30 performing companies would be listed in BSC 30, BSC index, right? But when we talk about listed companies on BSCs, there are thousands of companies. When we talk about the index of BSC steel, BSC steel would comprise of only the companies which are from steel industry. For example, we talk about BSC telecom, then only telecom companies would be existed in BSC telecom index. So this is how we actually form an index. It is a composite measure of all the available items. Then goal of measurement, validity. How would you measure the validity of? See, when you are trying to measure something, you should actually check whether it was valid or not. For example, you might try to check a fish, whether it can, run faster than an elephant or not on the land, right? So it is actually the wrong concept. You cannot measure whether a fish can travel on land faster than any other object or not, because fish lives in water. So you will be actually measuring fish activity, all the activities of fish when it is in water, right? So that is what validity is. You are trying to check whether you have actually measured the right thing or not. This is how we will be checking validity. Let me explain it with the help of three things. One is validity. Validity, the ability of a scale to measure what was intended to be measured, whether your scale is actually trying to measure what you really wanted to measure, right? For example, you might be willing to check whether which horse is better than the other horses, right? Maybe which horse is running faster than other, uh, or maybe which horse has a good appetite, or something like that. For that, you need to check whether whatever tool you have applied to measure the thing, whether it was actually measuring the same thing or same attribute or not. Then reliability, the degree to which measures are free from random error, therefore yield consistent results, whether they are actually checking the results correctly, consistently or not. Maybe sometimes it happens the tool has provided you with the good results in one time, but at this measurement of second time, it was not actually 100% valid. So this is why we check reliability along with validity. Then sensitivity, a measurement instrument's ability to accurately measure variability in stimuli or responses. Sensitivity is one step ahead of validity and reliability. When you know that validity and reliability are being checked, then you will be checking the actually sensitivity of that tool, whether it was actually being able to accurately measure the variability on the in the responses or not. This is also important in case of interviewer studies. Let us see it with the help of this example. When we talk about target A, when we talk about the signs, these are actually scattered. So these are not actually 100% reliable, because these are not providing consistent results. But when we talk about this scenario, yes, it looks consistent and providing high reliability results. And when we look at this, it seems reliable because these are providing you consistent results, but it is not valid because we were trying to target this particular mark, right? So this is how reliability and validity works. That's it. Let us discuss some true false. Number one, measurement is the process of describing some property of a phenomena, usually by assigning numbers in a reliable and valid way. Yes, measurement is actually the process of describing the property of a phenomena by assigning just numbers in reliable and valid way. You have to be very careful whether you are actually going to use nominal scale, in which case you are going to use ordinal or interval scale, or in which kind of study you will be using ratio scale. So it is true. Second, in measurement, whenever a number is used to assign a value to an observation, the researcher must assign this number according to some predetermined rule. Yes, you should have a predetermined rule to assign the value. For example, if you know that you are going to assign a value on the basis of interval scale, for example, on the basis of scale of 1 to 5, then you will be assigning all the values related to that particular question on the basis of 1 to 5 scale. This is true. Third, all measurement, particularly in the social sciences, contain error. Yes, all measures would have, little or more some errors in it. So it's 100% true. Yes. Fourth is, a scale can be thought of as a generalized idea that represents something of meaning. No, this is actually a concept which is presented as a generalized idea that represents something of meaning. So it is wrong, false. Next, correspondence analysis is the process of identifying scale devices that correspond to properties of a concept involved in a research process. It is actually operationalization of a concept, so it is false. Correspondence analysis is something else, and when we talk about operationalization of something, it is actually the process of identifying scale devices that correspond to properties of a concept involved in a research process, so it is false. Sixth is, a construct is a term used for concepts that are measured with single variables. No, that are measured with multiple variables. So it is false. Construct basically is a term used for multiple variables actually. Then seventh is, how we define a will affect the way we measure it. Yes, it's true. We define construct as per we are going to measure it. So it is very important to define construct properly. So it is true. Eighth is, an ordinal scale is the simplest type of measurement scale. No, simplest type of measurement scale is nominal scale, where we are just assigning values to people randomly. So it is false. Ninth is, the most sophisticated form of data analysis for a nominal scale is the average of the scores. Is it? No, not at all. Nominal scale properties mean the numbering system simply identifying things. That's it. So mathematical function like averaging should not be performed. Average has nothing to do with nominal scale. We are just trying to number the things just for the purpose of identification. For example, I mentioned the example of horses. For example, 10 horses are going to run in a race. You will be just providing them tags from 1 to 10, so you can just identify them, that yes, this was the horse number 1, 2, 3, or up to 10. That's it, nothing else. No mathematical equation is there. So it is false. 10, a measurement scale in which respondents are asked to rank items based on their preferences is called a nominal scale. When we talk about preferences, we are talking about ordinal scale. So it is false. Let us discuss some questions. Number 1, compare and contrast the 4 different levels of scale measurement. What are the 4 different levels of scale measurement? Number 1, it's nominal scale, then ordinal, then interval scale, and then ratio scale. Nominal scale basically represents the most elementary level of measurement. It assigns a value to an object for identification or classification purposes. The value can be a number, but doesn't have to be, like, because no quantities are being represented. You can even assign values like A, B, C, D up to Z. Then ordinal scale, ranking scales, allowing things to be arranged based on how much of some concepts they possess. They have nominal properties, but they also allow things to be arranged on the basis of how much of some concept they possess. Or you can say you can even compare the products here. Then interval scale has both nominal and ordinal properties, but also captures information about difference in quantities of a concept. Unlike ordinal scales, it captures relative quantities in the form of distance between the observations. Then when it comes to ratio scale, it represents the highest form of measurement. In that, it has all the properties of an interval scale. That means all the properties of nominal, ordinal, and interval scale, with the additional attribute representing absolute quantities. Interval scales represent only relative meaning, whereas ratio scales represent absolute value. Therefore, 0 has a meaning in that. It represents an absolute of some concept. For example, you can say, you can talk about the value of money. You can talk about the value of weight, distances, right? These are all ratio scale values. Then explain how index or composite measures are formed. How would you form a index measure or composite measure? I explained it with the help of example of BSC index. So you can define it this way. Third is, list the 3 criteria for good measurement. What are these 3 criteria for good measurement? Reliability, validity, and sensitivity. These 3 should be there while going for any kind of measurement. If these 3 are there, then it is considered as a good measurement. Then fourth is, what are the appropriate descriptive statistics allowable with nominal, ordinal, and interval scales? To calculate a mean and standard deviation, interval or ratio scale is required. Or if we talk about some non-parametric statistics, then you can go with some nominal and ordinal data as well. We will be discussing these things in detail in upcoming chapters as well, when we will be discussing mean, median, mode, and how do we go about parametric and non-parametric test. Then it would be more clear to you. But still, you should know, when we talk about numbers, parametric test, we are talking about either interval or ratio scales. But when we are talking about non-parametric test, we can manage with the help of nominal and ordinal scale as well. When we talk about the quality, we talk about ordinal scales. When we talk about the quantity, we talk about ratio scale, right? Then discuss the difference between validity and reliability. What do you mean by validity and what do you mean by reliability? First of all, you will be stating the definitions, and then the difference between the two key measurement is often confused. I know that because people are confused whether reliability is actually measuring something right or consistently performing. So reliability refers to the ability of a measure to obtain similar results over time and across situations. That is reliability, when you are actually consistent over time and across any kind of situation, you will be consistent. Though normal situations, not extraordinary or abnormal situations. We are talking about just normal situations here. Reliability is actually the degree to which measures are free from error. But when it comes to validity, it refers to the measure's ability to measure what we actually intended to measure, right? Whether we have actually measured the thing we wanted to measure or we have measured something else, like we discussed in case of that target example. Then last is, what is the difference between a conceptual definition and an operational definition? Yes, conceptual definition basically is a verbal explanation of meaning of the concept, right? But when it comes to operational definition, it's a definition that gives meaning to a concept by specifying the activities and operations necessary to measure it. It is actually very necessary when we talk about research studies, by like operationalizing the concept so as to define what are we actually going to study in the concept. That's it. Thank you. In our next video, we will be studying attitude measurement.